Welcome. Tonight, we are going to embark on a very quiet journey. As you settle into your bed, adjusting your pillow and finding that perfect spot of comfort, I want you to imagine the world around you in a slightly different way. We often think of the sky as an empty space, but it is actually a beautifully complex structure of invisible layers, each one serving as a shield, a filter, and a protector. Imagine the atmosphere as a soft, multi-layered blanket wrapped snugly around the Earth. It is a vast, translucent envelope that keeps us warm, keeps us safe, and allows everything we know to exist. It is the cradle of life, a thin skin of gas that separates our vibrant world from the cold, silent vacuum of the universe. Before we begin our slow ascent through these layers, if these gentle facts help you find the rest you deserve, please feel free to subscribe and join our quiet community. We are so very glad you are here with us tonight. The first thing to understand about this great blanket is that it isn't just drifting aimlessly through the cosmos. It is held firmly, yet gently, in place by the Earth's gravity. This constant pull ensures that the air stays with us, reaching out hundreds of miles high. Even though it feels weightless as you move your hand through the room, it is a massive, cohesive system that travels with our planet as we spin through the stars. This atmosphere does something remarkable that we often take for granted. It provides the pressure needed for liquid water to exist on our surface. We think of water as a constant, but it is the weight of the air pressing down on the oceans, lakes, and even the dew on a leaf that keeps it in its liquid form. Without this atmospheric pressure, the water would simply boil away into the void, leaving the world dry and barren. And perhaps most beautifully, the atmosphere is the medium for all sound. Without it, the Earth would be as silent as the moon. There would be no bird song, no sound of a distant stream, and no whisper of a breeze against the trees. The air carries the vibrations of the world to our ears, acting as a conductor for the music of life. Every word spoken and every breath taken is a gift from this invisible ocean of gas. As you lie there now, feeling the steady, rhythmic rise and fall of your chest, realize that you're at the very base of this magnificent tower of air. We begin our ascent here, at the very bottom, in the thickest part of the envelope where the air is rich and life is abundant. Let us move a little deeper into this first layer, the realm where we live, breathe, and dream. This first layer, the one we are nestled within right now, is called the troposphere. It is the most crowded, most active, and most vital part of our sky, even though it is the thinnest layer in terms of its vertical height. Compared to the vastness of space, it holds a secret, heavy significance. Imagine the entire weight of the sky above you. Amazingly, the troposphere contains about 75 to 80% of the atmosphere's total mass. It is as if the Earth is hugging the majority of its air close to its surface, keeping the richest, most substantial part of the blanket right where we can use it. This density is what makes the air feel so present, so tangible as it moves around us. The shape of this layer isn't perfectly uniform across the globe. It changes based on the warmth of the Earth below. At the equator, where the sun's rays are strongest and the air is warm and expansive, the troposphere stretches upward, reaching its thickest point. But at the north and south poles, where the air is cold and settles more densely, the layer becomes much thinner. It is a breathing, shifting envelope that responds to the temperature of the world it protects, rising and falling like the slow, steady breath of a sleeping planet. Think for a moment about the air moving into your lungs as you relax. It feels like a single, simple substance, but it is actually a precise and delicate recipe of elements. Most people are surprised to learn that the air we breathe is not primarily oxygen. About 78% of the air around us is actually nitrogen, a calm, stable gas that provides the bulk of our atmosphere and helps dilute the oxygen to a level that is safe for us. Oxygen, the life-giving element we depend on, makes up about 21% of this mixture. It is the perfect balance, refined over millions of years to support the complex dance of life. Between these two major components, there are other, more subtle guests in the air. Argon, a noble and unreactive gas, makes up nearly 1% of the air around us. It is always there, invisible and silent, drifting alongside the oxygen we crave. The remaining tiny fraction, just a whisper of the whole, is made up of carbon dioxide, water vapor, and other trace gases. Though they exist in small amounts, these gases are what plants use to grow and what helps keep our planet at just the right temperature for life to flourish. As you settle deeper into your pillow, try to feel the air in the room, not as empty space, but as a gentle, supportive presence. It is a physical thing, a sea of molecules that surrounds you, cradling you in its constant, soft embrace. You are never truly alone when you are wrapped in the atmosphere's care. You are simply resting at the bottom of a deep protective ocean of air that sustains everything you have ever known. It is a remarkable thing to consider that this air, which seems so weightless as you move your hands through it, actually possesses a physical weight of its own. Because we spend our entire lives submerged in it, we often forget that the atmosphere is constantly pressing against us, a soft and steady reminder of the world's presence. At sea level, the air is pressing down on everything, including you, with a force of about 14.7 pounds for every single square inch of your body. If you were to look at your thumbnail, the column of air resting directly on that small space weighs nearly 15 pounds, reaching all the way from your hand to the very edge of space. You might wonder why we don't feel this weight, or why it doesn't flatten the delicate structures of the natural world. The reason is a beautiful example of nature's balance. Our bodies are perfectly pressurized to match this weight. The fluids and gases inside of us push outward with the exact same force that the atmosphere pushes inward. We exist in a state of perfect harmony with the pressure of our environment, a quiet internal echo of the world outside. This balance is so seamless that we only notice it when it changes, perhaps as a slight popping in our ears when we drive up a mountain or fly in a plane. As you move higher into the sky, this pressure begins to decrease. This happens simply because there is less air above you to provide that weight. The higher you go, the thinner the air feels, as the molecules spread out, enjoying more space between one another. It is a gentle transition, a gradual lifting of the heavy blanket as you climb toward the stars. The very name we give to this protective envelope, the atmosphere, reflects its ethereal nature. It comes from the ancient Greek words atmos, meaning vapor, and sphera, meaning sphere. It is, quite literally, our sphere of vapor, a swirling, misty ball that keeps us safe. Within this sphere of vapor, the air does much more than just provide pressure and breath. It serves as a medium for the senses. In this lowest layer where we live, the air acts as a messenger. It is the vehicle that carries the most delicate information to our senses. When you step outside after a summer storm and smell the clean, metallic scent of rain on dry earth, a scent known as petrichor, it is the atmosphere that has carried those molecules to you. It brings us the sweetness of blooming jasmine on a night breeze and the crisp, sharp aroma of pine needles in a forest. Without the density of this layer, the world would be a place of sensory silence, devoid of the familiar fragrances that ground us in our surroundings. As you lie there, breathing in the quiet air of your room, you are experiencing the atmosphere at its most intimate. It is the bridge between the earth and your senses, a supportive, weighted presence that holds everything in its place. And while we can feel the air and smell the life it carries, we can also see its movements written in the sky above. As we move our focus from the air we feel to the sights that drift overhead, we begin to see how this vapor transforms, gathering itself into the soft white shapes that wander across the blue. In this sphere of vapor, the air holds a secret ingredient that makes life as we know it possible: water. While the atmosphere reaches hundreds of miles into the dark of space, nearly all of its water vapor, about 99% of it, is gathered right here in this lowest layer, the troposphere. It is as if the Earth is cradling its moisture close to its surface, keeping the life-giving rhythm of rain and dew within reach of the plants and animals that need it most. This water vapor is invisible, a ghost-like gas that moves silently among the nitrogen and oxygen molecules. But it is the architect of the beautiful landscapes we see when we look up at the sky. When you look out a window and see a soft white cloud drifting by, you are witnessing a delicate transformation. Clouds form when that invisible water vapor rises and begins to cool. As it loses the warmth of the ground, the vapor slows down and turns back into tiny microscopic droplets of liquid water or shards of ice. But these droplets are so light that they need a little help to gather together. They look for tiny seeds floating in the air, microscopic particles of dust blown from a distant desert, crystals of salt sprayed from the crest of an ocean wave, or even tiny bits of smoke from a forest fire. These particles, known as cloud condensation nuclei, act as a foundation. The water molecules cling to them, huddling together by the billions until a cloud becomes visible to our eyes. There is a quiet diversity in these formations. Meteorologists recognize 10 main types of clouds, each with its own personality and height. There are the high, wispy cirrus clouds that look like delicate strands of white hair pulled across the blue, made entirely of ice crystals because the air so high up is so very cold. Then there are the friendly, mid-level cumulus clouds, the ones that look like heaps of cotton or fluffy sheep grazing in a blue meadow. Each shape is a reflection of the wind and the moisture at that specific height, a visual map of the invisible currents flowing through the troposphere. Because of this concentration of water and the constant movement of air, the troposphere is the only layer where almost all of our weather occurs. It is here that the winds howl, the lightning flashes, and the gentle snow falls. Above this layer, the sky is mostly clear and still. But here, in the cradle of the world, the air is always mixing and churning. It is a dynamic, living system that works tirelessly to distribute water across the continents, ensuring that even the centers of great land masses receive the moisture they need to thrive. As we imagine ourselves rising through these clouds, floating upward past the fluffy white peaks of the cumulus and toward the thin, icy veils of the cirrus, we might notice a change in the sensation of the air. It isn't just that the air is becoming thinner or that the clouds are becoming more crystalline. There is a physical shift in the environment that we can feel deep in our bones. We begin to understand why the tallest mountains on our planet, reaching high into this layer, are often capped with white, even when the valleys below are lush and green. We are moving away from the warmth of the Earth's surface, entering a realm where the air begins to lose its heat, degree by steady degree. As we continue our slow, weightless ascent, you might notice that the air is losing its summer warmth. It feels crisper, now cleaner, and significantly cooler. This is one of the most fundamental rules of the troposphere. As you move higher, the temperature begins to drop. It seems counterintuitive at first. After all, as we climb, we are technically moving closer to the sun, but the atmosphere doesn't work quite like that. To understand why, imagine the Earth beneath you as a giant stone radiator. The sun's rays pass through the clear air of the upper atmosphere without warming it very much. Instead, that energy hits the ground, the forests, and the oceans. The Earth absorbs that heat and then slowly, steadily releases it back into the air directly above it. Because of this, the warmest air is always found at the very bottom, snuggled against the surface of the planet. As we move away from that supportive source of warmth, the air naturally begins to chill, losing the embrace of the ground. Scientists have a name for this steady cooling. They call it the environmental lapse rate. On average, for every kilometer we rise, about 0.6 of a mile, the temperature drops by approximately 6.5 degrees Celsius. If you prefer to think in Fahrenheit, that's a loss of about 3.6 degrees for every 1,000 feet of elevation. It is a predictable, rhythmic decline, a cooling that happens step by step as we leave the comforts of the lowlands behind. It is as if the atmosphere is gently asking us to sleep or to slow down, to settle into the stillness of the heights. This cooling effect is why the great Oran mountains of our world hold on to their snow so tightly. You might be standing in a sun-drenched valley, feeling the humidity of a midsummer afternoon, but if you look up at the jagged peaks of the Alps, the Rockies, or the Himalayas, you see a world of permanent winter. Even in the height of the warmest season, those high-altitude slopes remain draped in white because the air at those heights simply isn't warm enough to melt the ice. The mountains reach into a different climate altogether, standing as silent, frozen sentinels above the green world below, existing in a state of perpetual, quiet frost. As we drift even higher, far past the reach of the tallest peaks and the highest eagle's flight, the cold becomes profound. By the time we reach the very top of the troposphere, the temperature has plummeted far below anything we usually experience on the ground. In this thin, high air, the temperature can settle at a staggering -60 degrees Fahrenheit, which is about -51 degrees Celsius. It is a dry, biting cold, a place where the air is incredibly still and the molecules move slowly in the deep, dark chill of the high sky. And yet, as we reach this freezing threshold, something strange happens. The steady cooling we've been tracking for miles suddenly begins to level off. We are approaching a boundary, an invisible ceiling that marks the end of the world of weather and the beginning of something entirely new. We have reached the top of the first great layer, a transition point where the rules of the atmosphere are about to change once again, moving from the churning air of the clouds into a realm of absolute glassy calm. At this high threshold, the steady cooling we have been tracking for miles finally begins to level off. It lingers as if the air itself is taking a momentary rest before deciding where to go next. This pause, this silent and invisible transition, is what scientists call the tropopause. It is the boundary, a thin and quiet skin that separates the churning world of weather from the layers that lie far above. You might imagine the tropopause as a great transparent lid, a soft ceiling that keeps most of the Earth's water vapor and moisture contained in the lower atmosphere. It is because of this lid that the clouds, the rain, and the storms stay close to the surface, nourishing the forests and the fields, while the air above remains remarkably clear and dry. Interestingly, this boundary is not fixed at a single height. It responds to the warmth of the sun and the turning of the seasons with a slow, rhythmic grace. During the height of summer, when the air near the ground is warm and expansive, the tropopause is pushed higher into the sky, stretching upward like a long, slow yawn. In the winter, as the air cools and becomes more compact, the boundary sinks lower, settling closer to the Earth. It is a seasonal pulse, a gentle rise and fall that happens twice a year, as the planet breathes in the cold and exhales the heat, shifting its layers to maintain a delicate balance. If you have ever looked out the window of a commercial airplane and seen a flat white carpet of clouds stretching toward the horizon while the sky above remained a perfect, cloudless void, you were likely hovering just near this boundary. Commercial jet pilots often seek out the space just above the tropopause for their long journeys across the world. They do this because once they cross this invisible line, they leave the turbulent, tumbling air of the troposphere behind. Above the tropopause, the air is remarkably stable and calm, allowing the aircraft to glide through the sky with a stillness that feels more like floating than flying. It is a place of profound peace, far removed from the winds and the sudden shifts that play out in the world below. As we linger at this threshold, the sky begins to change its appearance in a way that feels both beautiful and slightly mysterious. The familiar bright blue we see from our gardens begins to fade, replaced by a deeper, darker, more velvety indigo. It is a color that feels heavier and more profound, a visual scene that the protective blanket of the atmosphere is growing thinner and that the void of space is drawing nearer. At this height, the air is so sparse and the oxygen molecules so far apart that a human could not survive for more than a few moments without the assistance of pressurized cabins or oxygen tanks. It is a reminder of how precious each of our breaths is, and how carefully the earth provides for us in the lower reaches where the air is thick and supportive. With a final look back at the swirling clouds beneath us, we prepare to step upward, leaving the world of weather behind as we enter the calm, steady embrace of the stratosphere. As we cross the invisible threshold of the tropopause, we enter a realm of profound and enduring stability. This is the stratosphere, a part of our atmosphere that feels distinctly different from the restless world below. If the troposphere is a place of movement and change, the stratosphere is a place of deep, undisturbed quiet. Take a slow, deep breath and imagine yourself floating upward into this calm, clear expanse, where the air becomes smooth and the chaotic winds of the surface fade into a distant memory. This layer of our atmosphere is vast, beginning at about 6 miles above the ground, just beyond where the highest mountain peaks and the tallest storm clouds reach, and extending upward to a height of roughly 31 miles. It is a wide, open corridor that serves as a silent guardian for the planet. As we move through it, the air feels thin and light, unlike the air we breathe near the ground, which is heavy with moisture and the scents of the earth. The air in the stratosphere is remarkably dry. It contains almost no water vapor, which is why the storms, the humidity, and the heavy gray clouds of the lower world are left far behind. In this dry desert of the sky, the view is one of eternal clarity. Because there is so little moisture, there are almost no clouds here to obstruct the view of the stars or the deep curve of the earth. However, on very rare occasions, near the freezing winter poles, you might see something truly breathtaking: nacreous clouds. These are often called a mother-of-pearl clouds because of the way they shimmer with soft iridescent colors. They glow with a ghostly pearlescent light, appearing like ripples of opal or silk against the darkening sky. They are among the highest clouds in the atmosphere, formed of tiny ice crystals that catch the sun's rays long after the world below has tucked itself into the shadows of night. The name stratosphere comes from the Latin word strata, which means layers. In the troposphere where we live, the air is constantly mixing, rising, and falling in restless, vertical currents. But here, the atmosphere is stratified. It is arranged in distinct horizontal layers, like a stack of soft, invisible blankets resting peacefully on top of one another. Because the air does not churn or tumble, there is very little turbulence. It is a place of absolute glassy stillness, where every molecule seems to know its place. This stability has a significant effect on the world below. Because the air here does not mix vertically, anything that managed to reach the stratosphere tends to stay there for a long time. When a massive volcanic eruption occurs, it can sometimes blast fine ash and sulfur aerosols high enough to penetrate this layer. Without rain to wash the air clean or winds to blow the particles back down, these tiny fragments can linger for years. They drift slowly around the globe like a thin, dusty veil, subtly reflecting the sun's light and cooling the entire planet. It is a quiet reminder of how even the most distant layers of the sky are intimately connected to the temperature of the soil beneath our feet. As we continue our gentle ascent through these silent, stratified levels, we begin to notice a strange and beautiful paradox. In the world below, we grew accustomed to the air getting colder the higher we climbed. But here, as we drift deeper into the stratosphere, the air begins to do something unexpected. Instead of freezing, it begins to grow warmer. We are approaching a hidden source of energy, a warm embrace that protects all of life from the harshness of the sun. We are moving toward the heart of the stratosphere, where a thin layer of molecules performs a miracle every single day. As we drift further into the calm of the stratosphere, we encounter one of the Earth's most vital and silent protectors, the ozone layer. This isn't a separate shell or a solid wall, but rather a region within the stratosphere where the concentration of ozone molecules is at its highest. While ozone can be found in small amounts throughout the atmosphere, it gathers here between 9 and 18 miles above the surface, forming a delicate, invisible veil that stands between us and the raw power of the sun. It is a place of profound importance, yet it exists so quietly that we often forget it is there, working tirelessly to keep the world below in balance. To understand ozone, we must think of the oxygen we breathe every day. The air that sustains us is made of oxygen molecules consisting of two atoms joined together. But here, under the touch of intense solar radiation, these molecules are transformed. Ozone is a special, rare form of oxygen made of 3 atoms instead of 2. It is born from the sun's own energy, and in a beautiful cycle of natural harmony, it exists to temper that very same energy for the world below. It is a testament to the Earth's ability to create exactly what it needs to survive, using the sun's own strength to build a shield against it. The primary role of this layer is to act as the planet's sun shield. It is incredibly efficient at its job, absorbing about 97 to 99% of the sun's medium-frequency ultraviolet light. Without this quiet, constant absorption, the sun's rays would be far too harsh for most forms of life to endure on the surface. We can imagine the ozone layer as a pair of celestial sunglasses for the Earth, softening the glare of the universe so that the delicate life below, the flowers, the forests, and our own skin, can thrive in safety and comfort. There is a fascinating and unexpected physical consequence to this protective work. As the ozone molecules soak up the ultraviolet radiation, they convert that energy into heat. This is the secret behind the strange warming we noticed as we climbed higher into this layer. In the troposphere below, the air is warmed by the ground, so it naturally cools as you move away from the Earth. But here, the ozone layer acts like a gentle heater suspended in the sky. By absorbing the sun's rays, it warms the surrounding air, creating what is known as a temperature inversion. In this part of the atmosphere, the higher you go, the warmer it becomes. This inversion is what gives the stratosphere its incredible stability and its peaceful, unruffled nature. Because the warm air sits on top of the cooler air below, it prevents the kind of vertical churning and storminess we see near the ground. It creates a ceiling of warmth that keeps the atmosphere organized and still. It is a place of absolute quiet, a high-altitude sanctuary where the air is thick with the silent energy of the sun, held in check by a thin, invisible layer of 3-atom molecules. As you settle deeper into your bed, try to visualize this shield high above you. It is always there, even in the deep dark of night, a legacy of the sun's interaction with our air. It is a soft, protective embrace that wraps around the entire globe, ensuring that the light reaching your window tomorrow morning will be gentle and life-giving. We are safe beneath this canopy of molecules, drifting through a region of the sky that exists solely to preserve the harmony of the world beneath it. Take a slow, deep breath and feel the stillness of this protective layer, knowing that you are cradled by the very air itself. While the stratosphere may feel like a distant, uninhabited void, it is not as empty as one might imagine. Even in this high, dry, and seemingly inhospitable realm, life finds a way to linger. It is a quiet, microscopic kind of life. Scientists have discovered that various species of bacteria and fungi drift through the stratosphere, carried upward by powerful storms or volcanic eruptions. These tiny organisms are remarkably resilient, surviving the intense ultraviolet radiation and the freezing temperatures of the lower stratosphere. They float there, miles above the highest clouds, like invisible dust motes caught in a beam of sunlight. It is a humbling thought that even in the loneliest reaches of our sky, there is a pulse of life, waiting for the wind to eventually carry it back down to the world of soil and water. Higher still, or perhaps right at the threshold where we entered this layer, there are travelers with wings. The Ruppel's vulture holds the record for the highest flying bird ever recorded. These majestic creatures have been known to soar at the very bottom of the stratosphere, reaching altitudes of over 37,000 feet. At that height, the air is thin and the oxygen is scarce. But the vulture glides with effortless grace, its massive wings catching the steady horizontal winds. It is a solitary, silent journey, far above the reach of predators or the noise of the world below. From that vantage point, the vulture sees the curve of the earth and the deep, darkening blue of the high sky, a perspective of peace that few living things will ever know. We also send our own silent observers into this calm expanse. Weather balloons, large and translucent like ghostly jellyfish, are launched every day from stations across the globe. As they rise through the troposphere and into the stratosphere, they expand, sometimes growing as large as a house in the thinning air. They carry small packages of instruments called radiosondes, which whisper back data about temperature, pressure, and humidity. These balloons drift peacefully for hours, suspended in the stillness, providing us with a map of the invisible forces that shape our weather. They are like quiet thoughts sent upward, seeking to obtain a better understanding of the mysteries of the air that sustains us. In this high-altitude sanctuary, the very nature of sound begins to change. Because the air is so thin, with fewer molecules to bump into one another, sound does not travel the same way it does on the ground. Sound requires a medium to move through, and as the air thins, that medium becomes sparse. A voice here would seem muffled and a shout would fail to carry. It is a place of profound, absolute silence. If you were to stand in the stratosphere, you would hear nothing but the soft, steady rhythm of your own heart. It is a stillness so deep that it feels like a physical presence, a weightless, velvet quiet that wraps around you, inviting you to let go of the noise and the chatter of the day. It is the silence of the universe beginning to make itself known. As we linger in this quiet, we begin to notice that the air is not entirely still. While it lacks the chaotic storms of the layer below, it possesses its own form of movement. There are invisible rivers flowing through this space, vast ribbons of air that travel at incredible speeds, guiding the path of the world's weather. We are beginning to follow these silent currents now, moving with them as they snake around the globe high above the clouds. Let yourself drift as if you are weightless, caught in one of these gentle, powerful streams of air that connect the distant corners of the earth in a never-ending cycle of motion. Following these invisible rivers, we find ourselves at the edge of a great, fast-moving flow. These rivers are known as the jet streams. Imagine these narrow, shimmering ribbons of air winding their way around the planet like silk threads. These are not like the winds we feel on the surface, which gust and buffet against the trees. Instead, the jet streams are vast, consistent currents that dwell primarily near the tropopause, the invisible boundary we have just traversed. They exist at the very top of the troposphere and the very beginning of the stratosphere, acting as a high-altitude highway for the atmosphere's energy. Though they feel like a gentle magnetic pull as we drift along with them, these winds possess an incredible silent power. In the very core of these streams, the air can reach speeds of over 200 miles per hour. It is a staggering velocity, yet because the air is so thin and the flow is so broad, there is no roar of wind, no chaotic turbulence. It is a swift, steady glide across oceans and continents. If you were to look down from this stream, you would see the world passing by with remarkable speed, while you remain suspended in a state of perfect flowing calm. What creates these great circling currents? It is a grand conversation between the Earth's extremes. The jet streams form in the regions where the cold, dense air from the polar regions meets the warm, buoyant air from the tropics. This meeting of temperatures creates a steep pressure gradient, and as the Earth rotates, it twists these winds into the long, wandering paths we see today. It is as if the Earth is constantly trying to balance its breath, swirling the chill of the north and the warmth of the equator together in a never-ending dance. This dance keeps our climate in a delicate state of movement, preventing any one region from becoming too stagnant. If you have ever been on a long-distance flight that arrived much earlier than expected, you may have been a passenger on one of these invisible rivers. Commercial pilots are master navigators of these currents. When traveling from west to east, they seek out the jet streams, positioning the aircraft within the heart of the flow to use the wind as a powerful tailwind. The airplane hitches a ride on the planet's natural momentum, saving thousands of gallons of fuel and cutting hours off the journey. It is a beautiful thought that even our modern machines rely on the ancient natural rhythms of the sky to find their way home. There are 4 of these major rivers encircling our world, mirroring one another in the north and the south. In each hemisphere, there is a polar jet stream and a subtropical jet stream. The polar jets are often the most energetic, wandering like a meandering river through the high latitudes, while the subtropical jets flow with a slightly more relaxed pace closer to the equator. Together, they form a crown of moving air that encircles the globe, a testament to the interconnectedness of our atmosphere. What happens in the cold Arctic air eventually ripples down through these streams to affect the weather in the sun-drenched tropics. As we move beyond these racing winds, the sensation of speed begins to fade, replaced by a sense of climbing even higher into the unknown. The air around us is growing even thinner, even more. We are leaving the influence of the jet streams behind and rising toward a new ceiling, a place of transition where the air reaches a peak of warmth before the great cold of the middle atmosphere begins. We are approaching the stratopause, the final boundary of this stable blue layer where the curvature of the Earth becomes a breathtaking reality. Feel yourself rising lighter than the air itself as we leave the rivers of wind for the vast, open silence of the heights. As we continue our slow, weightless ascent, we reach a quiet peak in our journey. We have arrived at the stratopause. This is a thin, invisible boundary, a moment of pause between the layer we are leaving and the one we are about to enter. It sits roughly 31 miles above the ground, a height that few humans ever experience firsthand. Here, the air reaches a surprising milestone. In this specific region, the temperature reaches its local maximum. Because of all the sun's energy absorbed by the ozone just below us, it is warmer here than at any other point in the middle atmosphere. It is a gentle, final pocket of warmth, a lingering breath of the sun's power before the environment changes once again. Take a slow, deep breath and imagine the perspective from this height. Looking down, you are now hovering above 99.9% of the Earth's atmosphere by mass. Almost everything that makes up our air, the clouds, the storms, the oxygen that feeds the great forests, and the winds that carry the birds, is now tucked safely beneath you like a thick, heavy quilt. Because so much of the atmosphere's substance is concentrated near the surface, the air pressure here has dropped to almost nothing. It is only about 1,000th of the pressure you would feel standing on a beach at sea level. The heavy weight of the world's air has been lifted, leaving you in a place of vast, thin clarity. From this vantage point, the view of our home begins to change in a profound and beautiful way. The horizon is no longer a straight line stretching infinitely into the distance. Instead, you can clearly see the gentle, elegant curvature of the Earth. The planet reveals itself as a great blue sphere cradled in the immense silence of the universe. The bright blue glow of the lower atmosphere clings to the surface like a luminous, protective veil, and above it, the sky transitions into a deep, velvety indigo that hints at the dark vacuum just a little further up. It is a moment of immense pace, seeing the world not as a collection of places, but as a single, finite, and precious home. There are no signposts here and no physical walls to mark our progress. The transition through the stratopause is entirely seamless, a silent passing of a guard. If you were floating through it, you wouldn't feel a bump or a change in the movement of the air. The only way to know you have crossed this threshold is by observing the subtle shift in the temperature. For the last several miles of our climb through the stratosphere, the air has been getting gradually warmer as we moved closer to the ozone's heat. But now, as we pass this invisible ceiling, that trend begins to reverse. The warmth of the sun-drenched ozone starts to fade away, and a new biting chill begins to take hold. We are leaving the calm stability of the stratosphere behind. As we move upward, the silence deepens even further. We are entering the realm of the middle sphere, a place of mystery and extreme conditions that sits far beyond the reach of our daily lives. The comforting, dense layers of the lower atmosphere are far below us now, and the air is becoming so thin that it can no longer hold on to the sun's heat. Feel the shift in the environment as we begin to drift into a region defined by its vast icy reaches. We are moving toward the coldest part of our world, leaving the sun-warmed heights for the shadows and the frost of the deep middle sky. We have now crossed the threshold into the mesosphere, the great middle sphere of our sky. It is a vast, invisible corridor that stretches from about 31 miles to 53 miles above the Earth's surface. Imagine this space as a quiet, lonely frontier, far removed from the bustling life of the ground and even the steady paths of commercial jets. Here, the air is so thin that it feels almost like a memory, yet it remains a vital part of the layers that shield us. As you drift through this layer in your mind, let the stillness of such a high altitude settle over you. Because of its unique position, the mesosphere is surprisingly difficult for us to explore. It exists in a sort of no man's land for our technology. It is too high for even the most advanced research planes to reach, as the air lacks the substance needed to provide lift for their wings. At the same time, it is too low for satellites to orbit. The thin gases here would still create enough friction to pull a satellite out of its path, causing it to lose speed and fall. Because it remains so elusive, scientists sometimes affectionately call it the ignosphere. It is a place that guards its secrets well, tucked away in the high, dark reaches where our tools cannot easily go. It reminds us that even in our modern world, there are still vast, quiet places that remain largely untouched and mysterious. As we move higher through this layer, the temperature begins a dramatic and steady descent. In the layer below, the ozone kept the air relatively warm by absorbing the sun's energy, but here, that protection has faded away. There are no special gases here to trap the heat, so the temperature plummets as we climb, dropping further and further into a deep, biting frost. By the time we reach the upper limits of the mesosphere, we will have arrived at the coldest naturally occurring place in our entire planetary system. It is a region of profound chill, where the warmth of the Earth is a distant memory, and the cold of the deep universe begins to make itself known. Take a slow, deep breath and imagine this cold not as something harsh, but as a deep, still quiet. It is the chill of a clear winter night when the stars are at their brightest and the world below is tucked away in sleep. In this thin, freezing air, the sky begins to feel more like space than like Earth. You are floating in a realm of pure crystalline stillness, far above the clouds, the wind, and the weather. The air here is far too thin to carry the sounds of the world below, leaving you in a state of absolute peace as you move through the shadows of the deep sky. The darkness here is becoming more pronounced, a rich and heavy velvet that prepares us for the wonders that happen only in this freezing, thin air. As the temperature continues to drop, the environment becomes a stage for some of the most beautiful and fleeting displays in nature. We are now suspended in the coldest part of our world's protective envelope, looking out into the dark, where the first sparks of the outer universe begin to appear. Feel the immense, cool weightlessness of this middle sphere as we prepare to see what happens when the debris of space meets this icy wall of air. It is in this freezing, silent expanse of the mesosphere that Earth provides one of its most vital and beautiful services to the life below. Though we have described this air as incredibly thin, it acts as a powerful, invisible shield for our planet. This layer is the primary place where meteors, those wandering fragments of rock and metal from the far reaches of the solar system, find their journey finally coming to an end. As we float in this icy darkness, we are standing on the front lines of Earth's defense, watching the quiet protection of our atmosphere in action. When a meteor enters the mesosphere, it is traveling at an incredible speed, often tens of thousands of miles per hour. Even though the gas molecules here are spread far apart, the sheer velocity of the meteor causes it to collide with them with immense force. This creates intense friction, and that friction generates a sudden, searing heat. In the blink of an eye, the surface of the rock begins to melt and vaporize, turning into a glowing trail of superheated gas. From our perspective on the ground, miles and miles below, we see this as a shooting star, a fleeting, magical scratch of light across the night sky. It is a beautiful paradox that here, in the coldest part of our world's envelope, we find such intense, brief moments of heat. These streaks of light are the soundless collisions of the cosmos and our home. If you were here, you would see these sparks igniting in the dark, brilliant and silent, like embers from a distant fire. They do not make a sound in this thin air. They simply glow with a fierce white or green intensity before fading back into the velvet shadows. You might imagine that these events are rare, something to be wished upon only a few times a year. However, the truth is much more profound. Scientists estimate that millions of meteors enter the Earth's atmosphere every single day. The vast majority of them are no larger than a tiny grain of sand or a small, smooth pebble. It is humbling to think that something so small, a mere speck of cosmic dust, can create a light so bright it can be seen from the surface of the Earth. These tiny travelers have drifted through the vacuum of space for billions of years, only to be welcomed home by the protective embrace of the mesosphere. As these meteors burn up, they leave behind a trail of microscopic debris, a fine meteor smoke that lingers in the upper reaches of the sky. The mesosphere filters out these incoming objects, ensuring that only the rarest and largest ever reach the ground. For the rest, their legacy is simply a moment of beauty and a scattering of stardust in the cold air. Imagine yourself resting here, safely suspended in this layer, watching the sparks of the universe ignite and then softly fade into the dark. Each flash is a reminder of the vastness of the space beyond and the gentle strength of the air that keeps us safe. The sky here is a canvas of fleeting light, where the ancient past of the solar system meets the quiet present of our atmosphere. As the last of a bright trail disappears, leaving only the deep, cold blue-black of the high sky, we begin to notice that the dust left behind by these falling stars starts to behave in a very peculiar and beautiful way in the freezing heights above us. We watch the sparks fade, leaving the dark still and silent once more as we prepare to see what the cold and the dust create together in the twilight. As the last embers of those meteors fade into the dark, they leave behind a silent gift for the upper atmosphere. That fine, microscopic debris, the meteor smoke we spoke of, doesn't simply vanish. It lingers in the freezing thin air of the upper mesosphere, waiting for a partner. In this extreme cold, even the tiniest, most elusive molecules of water vapor find their way to these particles of space dust. They cling to them, freezing instantly into microscopic crystals of ice. This process gives birth to the most elusive and beautiful clouds that is in existence, the noctilucent clouds. Their name comes from the Latin for night shining, and they are unlike any cloud you have ever seen from a park bench or a car window. While the clouds we know, the ones that bring rain or shade, dwell miles below us in the thick air of the troposphere, these night-shining clouds exist at the very edge of the sky, nearly 50 miles above the Earth's surface. They are the highest clouds in our world, sitting in a realm where the air is 100,000 times thinner than at sea level. Imagine looking up into a sky that has already surrendered to the night. The sun has dipped far below the horizon, and the stars are beginning to emerge in their fixed positions. But high above, where the curve of the earth hasn't yet blocked the sun's rays, these icy clouds are still bathed in light. Because of this unique geometry, they appear to glow from within, casting a ghostly electric blue or shimmering silver light against the deep velvet of the twilight sky. They look like luminous ripples on the surface of a dark, silent ocean, or like delicate threads of silk woven by the wind. If you were to drift through this layer, you would find yourself surrounded by a thin, icy vapor. It is a place of profound stillness and crystalline beauty. These clouds are a bridge between our world and the vacuum of space, formed from the union of terrestrial water and celestial dust. They remind us that even in the coldest, most desolate parts of our atmosphere, there is a capacity for light and warmth. The colors, those electric blues and pale metallic whites, are soft on the eyes, a cool fire that doesn't burn but simply glows with the memory of the sun. As you rest in this high frozen gallery, you can see the intricate patterns these clouds form. They are often shaped into long parallel bands or delicate curls, revealing the secret movements of the air at the edge of the world. They are a visual map of the invisible forces at play. You are floating now, weightless and calm among these silver veils. The air is unimaginably thin, and the silence is absolute. It is a sanctuary of ice and starlight, a place where the debris of the cosmos is transformed into a shimmering work of art. As we drift through this thin, icy vapor, it is easy to feel that we are in a place of perfect stasis. Yet, even in this apparent stillness, there is a hidden pulse. The mesosphere is not a stagnant place. It is a region of constant rhythmic motion. Just as the tides of the ocean rise and fall against the shore, the very air here is subject to vast, invisible waves that travel up from the world below. As we linger here among the night-shining clouds, we begin to feel the first gentle tug of these atmospheric rhythms, the deep breathing of the planet itself. As we continue our journey through the mesosphere, we begin to notice that this thin, frigid air is never truly still. Much like the vast oceans far below us, the atmosphere experiences its own version of tides. These are not waves of water, but great, sweeping undulations of air. These atmospheric tides are caused by the same celestial forces that pull at our seas, the gravitational pull of the moon and the rhythmic heating of the sun. Every day, the entire atmosphere breathes in and out, expanding and contracting in a slow, steady cycle that is most pronounced here in the middle of the sky. It is a quiet, powerful pulse that connects the surface of the earth to the very edge of space. A reminder that we are part of a larger celestial clockwork. Rising from the lower layers of the atmosphere are other invisible travelers known as gravity waves. Imagine a suit being dropped into a still pond. The ripples that spread outward are much like these waves. They are often born far below us, triggered by air flowing over massive mountain ranges or the energy released by a powerful thunderstorm. These waves carry momentum and energy upward, traveling through the troposphere and the stratosphere until they reach this thin, high realm. They are like the echoes of the world below, finally reaching the quiet heights of the mesosphere, where they break like waves on a distant, invisible shore. As these gravity waves move through the thin air, they can cause the temperature to fluctuate wildly. In one moment, the air might be steady, and in the next, a passing wave can shift the temperature by dozens of degrees in a matter of minutes. Sources says this constant motion serves a vital purpose. It helps to mix the chemicals in the upper atmosphere. In this near vacuum, where molecules are few and far between, these waves act like a gentle hand, stirring a vast, invisible cauldron, ensuring that the composition of our air remains balanced and whole. It is a reminder that even in a place that looks like an empty void, there is a complex and dynamic system at work, a hidden architecture of movement. The mesosphere is a place of paradox. It is incredibly empty, yet it is filled with constant, restless motion. It is a realm of shadows and silver clouds, yet it is governed by the same physical laws that guide the tides of the deep blue sea. We are drifting now, carried by these invisible currents, feeling the rhythmic sway of the planet's breath. It is a soothing, predictable motion, like being rocked in a cradle made of starlight and thin air. But as we continue our ascent, the air grows even thinner, and the temperature begins to drop to its final, deepest minimum. We are approaching the very ceiling of this layer, a place where the warmth of the earth is a distant memory. We are moving toward the absolute coldest point in the natural world, a threshold of profound stillness and unimaginable chill. We have arrived at that threshold now, the very summit of the middle atmosphere. This is the mesopause, a thin and invisible boundary that marks the end of the mesosphere and the beginning of the next great layer. It is a place of profound silence, far above the world we know, where the air has become so thin that it is nearly impossible to imagine. Here, at this specific height, we find ourselves at a remarkable point in the geography of the sky. The mesopause is the coldest naturally occurring place on Earth. While we often think of the frozen reaches of the poles or the dark depths of the ocean as the most frigid environments, they are mild compared to the chill of this high ceiling. In this narrow band of space, the temperature can drop as low as minus 143 degrees Celsius, which is approximately minus 225 degrees Fahrenheit. It is a temperature so extreme that it seems to belong to the void between the stars, rather than our own planet. At this depth of cold, everything is still. There is no moisture here to form the soft snow we see on the ground. Instead, there is only the biting crystalline purity of the high atmosphere. This extreme cold is a result of the unique way the atmosphere radiates heat away into space at this altitude, creating a permanent icy shadow that wraps around the globe. Even the coldest winter night in Antarctica is warm by comparison to the stillness found here. As we linger in this quiet frozen realm, we can observe a subtle but significant change in the very nature of the air around us. Throughout all the layers we have traversed so far, from the ground where we breathe up to this great height, the gases that make up our atmosphere have been thoroughly mixed together by the wind and the constant movement of weather. This vast region is often called the homosphere because the proportions of nitrogen, oxygen, and other gases remain constant. But here at the mesopause, that long-standing harmony begins to shift. We are entering a transition where the composition of the air begins to change significantly for the first time. Because the air is so thin and the molecules are so far apart, they no longer bump into each other enough to stay mixed. Instead, they begin to settle and sort themselves out according to their own weight, much like layers of oil and water in a glass. The heavier gases, like the nitrogen and oxygen we depend on, tend to stay in the lower regions, held more tightly by the Earth's gravity. Above us, the lighter gases begin to dominate. We can imagine atoms of helium and hydrogen, the lightest elements in the universe, drifting upward like tiny invisible bubbles rising through a vast dark ocean. This sorting process marks our departure from the familiar atmosphere of the lower world. We are moving into what scientists call the heterosphere, where the sky is no longer a single uniform blend, but a series of delicate layers, each one thinner and lighter than the last. It is a transition into a realm that feels more like the open cosmos than the earthly home we left behind. The air here is no longer a collective breath, but a collection of individual travelers, each finding its own level in the silence. As we prepare to cross the mesopause, take a slow, deep breath. Feel the stillness of this high, cold place. We have reached the absolute bottom of the temperature scale, the deepest winter of the sky. But as we look upward, the darkness of the space above begins to change. The extreme cold we are experiencing is about to give way to something entirely unexpected. We are about to step out of the shadows and into the vast, sun-drenched expanse of the thermosphere. Here, the rules of heat and cold will twist into a beautiful paradox as we enter a layer where the sun's energy reigns supreme, turning the very edge of our world into a realm of heat and light. Leave the frozen silence of the mesopause behind and imagine yourself drifting upward, crossing an invisible threshold into a vast and glowing expanse. We are entering the thermosphere, the fourth major layer of our atmosphere, and a place where the very nature of warmth begins to change. This immense region starts about 53 miles above the Earth's surface and stretches far out into the darkness, reaching heights of 372 miles or even more. It is a realm so vast that it dwarfs the layers we have already visited, acting as a grand, sun-drenched cathedral that stands between the world of air and the world of stars. The name of this layer tells us exactly what to expect. It comes from the ancient Greek word thermos, meaning heat. after the bitter, record-breaking cold of the layer just below us. The thermosphere welcomes the sun with open arms. Here, the air is no longer shielded by the ozone or the thick gases of the lower sky. It absorbs the most powerful, high-energy radiation the sun has to offer. Because of this constant bombardment of solar energy, the temperatures here can soar to staggering heights. On a day when the sun is particularly active, the temperature in the thermosphere can reach as high as 2,500 degrees Celsius, or roughly 4,500 degrees Fahrenheit. These are temperatures that would melt many metals, a fierce and invisible fire burning at the very edge of our world. However, as we float in this golden energetic space, we encounter one of the most beautiful paradoxes in all of science. If you were to step outside a protective craft and expose your hand to this 4,000-degree environment, you would not feel a searing heat. In fact, you would feel quite the opposite. Despite the incredible temperature readings, you would feel a deep, penetrating cold. To understand why, we must think about what heat really is. In our everyday lives, we feel heat when billions of energetic air molecules bump into our skin, transferring their energy to us. But here, at the edge of space, the air has become so incredibly thin that it is almost a vacuum. The individual atoms of oxygen and nitrogen are moving at incredible speeds, which is what we measure as temperature, but they are so far apart that they rarely ever touch one another, and they would rarely touch you. Imagine standing in a vast empty hall where a few tiny pebbles are being thrown at incredible speeds. The pebbles themselves have a lot of energy, but because there are so few of them, they can't warm the room. In the thermosphere, an atom might travel for several miles before it ever bumps into another atom. Because there are so few molecules to collide with your skin and transfer their energy, your body would lose its own heat to the emptiness of space much faster than the thin, hot air could ever warm you up. It is a place of high energy, but very little substance. It is a reminder that in the upper reaches of our world, the physical rules we learn on the ground begin to soften and fade. Here, the heat is a silent, microscopic dance of lonely atoms vibrating with the power of the sun in a space that feels as empty and cold as the moon. As we continue to drift through this thin, high-energy mist, we begin to realize that the thermosphere is not just a place of heat, but a vital protective barrier, catching the sun's harshest rays and turning them into a quiet, invisible glow that keeps the world below safe and cool. Take a moment to appreciate this strange, shimmering balance, a layer that burns with the heat of a furnace, yet remains as still and cold as the deepest night. As we drift further into this thin, high-energy realm, we begin to see the sun not just as a distant light in the sky, but as a dynamic, living force that shapes the very air around us. In this vast space, the thermosphere acts as Earth's primary filter, a tireless guardian that stands between us and the raw power of our star. Its first and perhaps most vital task is the absorption of high-energy S-rays and extreme ultraviolet radiation. These are forms of light so energetic that they would be deeply harmful to life if they ever reached the ground. But here, miles above the clouds, The sparse atoms of the thermosphere catch these rays, soaking up their energy like a vast, invisible smorgasbord. In doing so, the atmosphere sacrifices its own coolness, heating up to those incredible temperatures we spoke of, all to ensure that the world below remains gentle and safe. This process makes the thermosphere a very reactive place, one that is constantly changing in size and shape. You might imagine the atmosphere as a quiet, breathing entity. When the sun is particularly active, perhaps during a period of many sunspots or solar flares, it sends out a surge of extra energy. The thermosphere responds to this touch by heating up even more and expanding outward into space. It puffs up, growing thicker and reaching higher than it does during quieter times. When the sun settles into a more peaceful state, the thermosphere cools and contracts once more, settling back toward the Earth. It is a slow, rhythmic pulse that follows the cycles of the sun, a cosmic lung breathing in response to the light of our star. This breathing has a direct impact on the objects we have sent into the sky. Many of our low-orbiting satellites, and even the International Space Station, reside within these upper reaches. When the thermosphere expands during high solar activity, these satellites suddenly find themselves moving through air that is slightly denser than before. Even though the air is still thinner than any vacuum we can create on Earth, it is enough to create a tiny, persistent drag on the satellites. It is like a very soft, invisible wind pressing against them, gradually slowing them down and causing their orbits to decay slightly. Engineers on the ground must carefully watch the sun's activity so they can predict when the atmosphere will rise up to meet these silent, orbiting travelers, occasionally firing small thrusters to keep them at their proper height. It is a humbling thought to realize that this layer, which feels so empty and distant, is actually a vital shield. By absorbing the sun's harshest radiation, the thermosphere prevents the atmosphere below from being stripped away or chemically altered by the sun's intensity. It is the first line of defense in a complex system of layers that makes our planet a sanctuary. Without this high-altitude buffer, the delicate balance of gases we breathe would be under constant assault. Instead, we are tucked away beneath this protective canopy, shielded from the solar wind and the invisible fires of space. As we linger here in the quiet heights of the thermosphere, we also begin to notice that the air itself is becoming electric. Within this broad expanse of heat and thin gas lies another phenomenon, a ghostly overlapping region known as the ionosphere. It is not a separate layer in the traditional sense, but rather a state of being for the atoms that live here. Because the sun's rays are so powerful at this height, they often knock electrons off the gas atoms, leaving behind a sea of charged particles. This creates a shimmering, electric nature to the sky, a hidden world of energy that hums with the potential of the universe. We are now entering a realm where the atmosphere begins to act less like a gas and more like a mirror, a place where the invisible threads of human communication and the wild lights of the cosmos begin to intertwine. Take a deep, slow breath and feel the stillness of this electric height as we prepare to explore how this shimmering sea of particles connects the distant reaches of space to the world we know below. As we float here in the high, thin reaches of the thermosphere, we find ourselves within a ghostly, overlapping realm known as the ionosphere. This is not a separate layer with a defined beginning and end, but rather a region where the very nature of the air becomes electric. The ionosphere is a vast sea of ionized particles created by the relentless energy of the sun. Far above the clouds, the sun's ultraviolet rays and X-rays are so powerful that when they strike the sparse atoms of gas, they knock electrons free. This process, called ionization, transforms the air into a shimmering soup of charged particles, ions and free electrons that behave differently than the air we breathe on the ground. It is a place where the atmosphere stops being just a wreck and starts acting like a conductor, a delicate web of energy that responds to the rhythms of the sun. This electric nature gives the ionosphere a remarkable ability. It acts as a giant, invisible mirror for the world below. These charged particles allow certain radio waves to bounce off the upper atmosphere rather than escaping into the cold vacuum of space. Instead of traveling in a straight line out into the stars, the radio signals hit this ionized layer and reflect back down to Earth, curving around the horizon. It is a natural miracle of physics that has connected humanity for over a century, allowing voices and music to travel across vast distances that the curve of the Earth would otherwise block. You may have experienced this yourself on a quiet, still night. Perhaps you were scanning the dial of an AM radio and suddenly heard a station from a city hundreds or even thousands of miles away. A distant voice whispering through the static from a place you've never been. This happens because of the unique behavior of the ionosphere at night. During the day, the sun's energy creates a thick lower layer of the ionosphere that absorbs these radio waves. But when the sun goes down, that lower layer fades away, and the radio waves can reach much higher into the sky, bouncing off the more stable upper regions. This allows them to skip across the continent, leaping over mountains and oceans to reach your ears. It is a reminder that even in the deepest silence of the night, we are surrounded by invisible threads of connection, carried by the very air above us. The ionosphere is not a static thing. It breathes with the cycle of the day and the activity of the sun. It grows thicker and more energetic as the sun rises, reaching its peak intensity at noon, and then slowly shrinks and thins as the world turns toward the shadows. It is a dynamic, shifting environment, a shimmering sea of electricity high above our heads that responds to every solar flare and every quiet moment of the sun's cycle. When the sun is particularly active, this sea can become turbulent, sending ripples through the electric field that can even interfere with our modern satellites and GPS systems. As you lie there, imagine this vast, glowing ocean of particles suspended in the darkness above you. It is a realm of profound beauty and hidden energy, a silent protector that manages the flow of radiation and information. It is the place where the Earth's atmosphere truly meets the influence of the sun, creating a bridge between our world and the cosmos. And it is within this electric sea that the most spectacular of all atmospheric phenomena begins to take shape. The energy gathered here in these ionized heights is about to be transformed into a display of color and movement that has captivated the human imagination since the dawn of time. We are standing on the threshold of a great silent light show, as the invisible forces of the ionosphere prepare to reveal themselves in the most beautiful way possible. As we linger in this high electric region of the thermosphere, the invisible energy we've been discussing begins to manifest in a way that is truly magical. This is the birthplace of the auroras, known in the north as the aurora borealis and in the south as the aurora australis. These lights are not just beautiful, they are a visual record of the Earth's relationship with the sun, a sign that our planet is alive and reacting to the cosmos around it. Imagine the sun as a gentle but powerful source of energy, constantly breathing out a stream of charged particles called the solar wind. Most of the time, our atmosphere and magnetic field deflect this wind, keeping us safe and shielded. However, near the top and bottom of our world, the Earth's magnetic field lines curve inward, creating a natural pathway. This magnetic field acts like a soft, invisible funnel, gathering these solar particles and guiding them down toward the top of our atmosphere. When these particles arrive in the thermosphere, they find themselves in a space where the air is very thin but still present. Here, the solar particles begin to collide with the atoms of gas that make up our air. It is a quiet, microscopic encounter. When a particle from the sun strikes an atom of gas, it gives that atom a tiny boost of energy, momentarily exciting it. To release that energy and return to its peaceful, natural state, the atom must let go of that extra boost. It does this by emitting a photon, a single tiny particle of light. Because there are billions upon billions of these collisions happening every second, the sky begins to glow. It is as if the very air itself is waking up and singing in color. The specific colors we see depend entirely on which atoms are being touched by the solar wind and how high up they are. Oxygen atoms, which are quite abundant in these layers, are responsible for the most famous auroral color, a soft, luminous green that looks like liquid jade flowing across the stars. In the higher reaches of the thermosphere, where the air is even thinner, oxygen can also produce a rare, breathtaking crimson red. If you look closely at the edges of these dancing lights, you might see hints of other colors as well. These come from nitrogen atoms. When nitrogen is energized, it releases light in beautiful shades of violet, blue, and sometimes a delicate rose-like pink. These colors often appear as a fringe or a hem on the bottom of the glowing curtains, adding a layer of depth and complexity to the display. Watching these lights in your mind is a meditative experience. They move with a slow, fluid grace, rippling like heavy silk curtains caught in a very gentle draft. There is no sound, only a profound, heavy silence that stretches for hundreds of miles in every direction. The lights pulse and fade, then brighten again, following the invisible flow of the solar wind. As you visualize these ribbons of green and purple drifting through the dark, feel your own breath slowing down to match their rhythm. You're safe here, watching the most beautiful light show in nature from the comfort of your rest, protected by the very layers of air that are now glowing so softly above you, rippling in the eternal silence of the high sky. As we watch these colors drift, it is easy to lose a sense of just how high they truly are. These curtains of light are not just above the clouds, they are far, far beyond the world we know. Most of the auroras you see occur at a height of between 60 and 150 miles above the Earth's surface. To put that in perspective, a commercial airplane flies only about 6 or 7 miles high. These lights are soaring in a realm where the air is so thin it is almost a vacuum. Yet there is just enough substance to catch the sun's energy and turn it into art. Sometimes, when the sun is particularly active, the light reaches even higher. Rare red auroras can occur as far up as 200 miles. At this altitude, the oxygen atoms are so spread out that they take longer to release their energy, resulting in that deep, ghostly crimson that seems to touch the very edge of space. It is a vast, vertical landscape of light stretching upward like a silent cathedral made of nothing but glowing gas. Take a slow, deep breath and imagine yourself floating in that calm, crimson glow, far above the worries of the world below. If we were to travel even further away and look back at our home, we would see that these lights aren't just isolated patches. From the perspective of an astronaut in space, the auroras appear as a magnificent glowing ring centered around the Earth's magnetic poles. Scientists call this the auroral oval. It looks like a crown of light, a soft halo of green and violet that rests upon the top and bottom of the world, marking the places where our planet's magnetic shield is most open to the cosmos. From this distance, the Earth looks like a precious marble protected by a flickering, luminous veil. The way these lights move is never static. They are constantly shifting, swaying, and pulsing. This movement is a direct reflection of the solar wind, the stream of particles flowing from the sun. As the solar wind fluctuates, the auroras dance in response. It is a celestial choreography, a visual representation of the invisible forces that bind our solar system together. You can imagine the solar wind as a gentle breeze across a dark pond, creating ripples of light that travel for thousands of miles across the high atmosphere. Humans have stood on the ground and looked up at these lights for thousands of years. Long before we understood the science of atoms and magnetic fields, we told stories about them. To some, they were the spirits of ancestors dancing in the sky. To others, they were celestial bridges or the reflections of distant fires. These myths remind us of our long connection to the sky, a sense of wonder that has remained unchanged, even as our knowledge has grown. The auroras have always been a source of peace and mystery, a reminder that we live on a planet that is deeply connected to the stars. As we linger here in the quiet glow of the thermosphere, we begin to notice that the lights are not the only things sharing this lofty space. Floating among the ripples of green and violet are the silent, metallic travelers of the modern age. We are now at the height where human-made objects begin to circle the Earth, moving through the same thin air that fuels the aurora's fire. We prepare to move toward these orbiting wonders, seeing how they navigate the very edge of our world.
Floating here, in the quiet heights of the thermosphere, you might see a steady bright light moving gracefully across the backdrop of the stars. It isn't a meteor or a drifting planet, but a home, a human outpost drifting in the silent dark.
This is the International Space Station, or the ISS. It orbits our world at a height of about 250 miles. At this altitude, It is nestled within the upper reaches of the thermosphere, circling the Earth once every 90 minutes. Imagine the view from its windows. 16 sunrises and 16 sunsets every single day, as the station glides over oceans and continents, draped in the soft glow of the atmosphere. It is a place of profound solitude and beauty, a silver needle threading through the high, thin air. It is easy to think of the ISS as being in a total vacuum, far beyond the reach of Earth's air. But surprisingly, even at 250 miles high, the atmosphere hasn't quite ended. There is still a very thin, ghostly presence of gas molecules, so few that you could never breathe them, but enough to make their presence known. As the station hurtles through this thin veil at 5 miles per second, it encounters a tiny bit of resistance called atmospheric drag. It is as if the station is swimming through a sea of almost nothing, yet that almost nothing is still enough to gently push against the station's massive solar arrays, slowing it down ever so slightly over time. Because of this constant, gentle friction, the ISS is always slowly losing altitude, sinking back toward the denser air below. To prevent it from falling, the station must periodically fire its engines or be pushed by a visiting spacecraft. These maneuvers, known as reboosts, lift the station back into its proper orbit, ensuring it stays safely tucked within the upper reaches of the thermosphere. It is a delicate balance, a constant dance between the immense speed of the station and the lingering, invisible reach of the Earth's breath. Take a slow breath yourself, feeling the steady rhythm of your own heart, just as the station maintains its steady pulse around our world. This region, known as Low Earth Orbit, or LEO, is a busy corridor for our modern world. It is the home not just for the ISS, but for hundreds of other satellites that look down upon us. Some are communication satellites, carrying our voices and messages across the globe. Others are imaging satellites, silently watching the movement of storms, the growth of forests, and the shifting of the tides. They are like silent sentinels, orbiting in the stillness, connected to us by invisible threads of data while they drift through the thin, cold air of the high sky. They move in perfect harmony, guided by the laws of physics and the gentle pull of gravity. If you were to stand outside and look up from the hull of one of these satellites, you would notice a profound change in the scenery. Down on the ground, we are used to a bright blue sky during the day, but at this height, the sky is a deep, permanent black. Even when the sun is shining with a brilliant, unfiltered intensity, the space around it remains as dark as midnight. This is because the air here is too thin to scatter the sunlight into the blue colors we see from the surface. Here, the sun is a bright white orb set against an eternal velvet curtain of stars. It is a place of absolute clarity, where the light of the universe reaches us without the softening filter of the lower clouds. As we continue our slow, weightless ascent, we leave these metallic travelers behind, watching them diminish into tiny, steady sparks of silver. We are moving toward the final, most distant layer of our world's protective shell. The air is becoming so sparse now that the very idea of an atmosphere begins to change. We are approaching the edge of the envelope, where the Earth's grip begins to loosen, and the vast open ocean of the cosmos truly begins. Drift upward now, toward the very last boundary of home. We have climbed so high now that the word atmosphere begins to lose its familiar meaning. The dense, life-giving air of the valleys and the forests is a distant memory, and even the thin electric air where the auroras dance is now beneath us. We are entering the exosphere, the outermost layer of the Earth's protective shell. It is the very edge of the envelope, the final thin veil between our home and the infinite dark. Take a moment to imagine this space, a place of such profound emptiness and stillness that it feels less like air and more like a quiet, weightless transition into the stars. The exosphere doesn't begin with a sudden change in color or a flash of light. Instead, it starts roughly 370 miles above the surface at the top of the thermosphere and stretches outward until it eventually dissolves into the silent vacuum of deep space. From this height, the Earth below looks like a magnificent glowing marble, wrapped in its many layers of blue and white. But up here, the environment is defined by its incredible sparseness. It is the beginning of a long, slow fade. There is no sudden wall, no hard gate to pass through, only a gradual thinning of the world's breadth as it reaches toward the cosmos. In the air we breathe every day, molecules are in a state of constant, frantic motion, colliding with one another millions of times every second. But in the exosphere, the rules of the world change. The air here is so impossibly thin that a single atom of gas can travel for hundreds of miles through the darkness without ever hitting another atom. It is a lonely, silent journey for these tiny particles. They drift through the blackness like solitary travelers, guided only by the distant, steady pull of gravity and the gentle pressure of the sunlight itself. This emptiness creates a sense of peace that is difficult to find anywhere else, a place where the frantic movement of the lower world has finally settled into a slow, rhythmic, and solitary drift. Because this layer is the very top of the atmospheric stack, it acts as a filter for weight, while the heavier nitrogen and oxygen molecules stay closer to the surface where we live. The exosphere is composed almost entirely of the lightest elements in the universe, hydrogen and helium. These atoms are so light and buoyant that they sit atop everything else, like the finest, most delicate mist on the surface of a deep and quiet ocean. They are the pioneers of our atmosphere, the atoms that venture the furthest into the unknown, held to the earth by the narrowest of margins. As you drift in this quiet space, you might wonder where the earth actually ends and where space truly begins. The truth is, there is no clear upper boundary to the exosphere. It doesn't stop at a specific mile or kilometer marker. Instead, it simply grows thinner and thinner, the atoms becoming more and more spread out until they are indistinguishable from the solar wind that flows between the planets. It is a seamless transition, a reminder that our world is not a closed box, but a living system that breathes out into the universe. Feel the weightlessness of this thought as you settle deeper into your rest. You are at the very limit of what we call home. The air has become a ghost of itself, a soft whisper of hydrogen and helium that stretches out into the velvet blackness. We are moving beyond the concept of air as something we feel against our skin and toward the reality of space as a place where the earth still exerts a gentle, lingering influence. Even here, in the profound silence of the exosphere, we are still within the reach of the world's quiet embrace. As we continue to drift further out into this thin silver realm, we begin to see that this embrace reaches much farther than we ever imagined, touching the very light of the stars. As we drift further into the silence of the exosphere, we find that the Earth does not simply end. It lingers. It reaches out in a way that is invisible to our eyes, yet deeply profound. Within this vast, thin space, there is a phenomenon called the geocorona. It is a part of the exosphere made entirely of hydrogen atoms, forming a luminous cloud that surrounds our planet. This cloud glows with a very specific soft ultraviolet light, a quiet radiance that marks the final frontier of our home. It is a reminder that even in the deepest dark, there is a part of the Earth that remains, glowing softly against the backdrop of the stars. This geocorona is far larger than we might imagine. It doesn't just hug the planet, it stretches out into the void for nearly 390,000 miles. To put that into perspective, the moon is usually about 238,000 miles away. This means that, in a very real sense, the Earth's atmosphere actually touches the moon. When the Apollo astronauts stood on the lunar surface and looked back at the Earth, they were technically still within the outermost, thinnest reach of our world's gaseous envelope. They were walking through a haze of earthly hydrogen, even as they looked out at the craters of another world. It is a comforting thought to know that our home extends its hand so far, providing a faint silver bridge between us and our closest celestial neighbor. This glow is incredibly faint, a ghostly presence that can only be seen with the help of special instruments and cameras that can detect ultraviolet light. To us, the space between the Earth and the Moon looks like a perfect empty vacuum, but the geocorona reveals it to be a bridge. It is a thin, ethereal veil of atoms that connects us to the rest of the solar system. It reminds us that Earth's influence and its gentle protection reach far deeper into the dark than we ever dared to dream. We are not a lonely island in the blackness. We are a planet with a long, luminous reach, casting a soft, invisible light into the distance. As you lie there, imagine this vast, invisible halo surrounding you and the entire world. It is a quiet, steady presence, a shell of light that cradles the moon and guards the threshold of space. It is the furthest extent of what it means to be home. But even here, at the very edge of the Earth's grasp, things are slowly and peacefully changing. The atoms that make up this beautiful geocorona are restless travelers. They are at the very limit of gravity's power. And for some of them, the pull of the Earth is no longer enough to keep them close. We begin to contemplate the slow, silent escape of these atoms, the way our atmosphere gently breathes its smallest pieces out into the great wide universe, a process as natural and rhythmic as your own breathing. As we look out into that vast, glowing geocorona, we begin to realize that our atmosphere is not a static thing. It is alive in its own way, constantly shifting and moving. Every single day, a small, quiet amount of Earth's atmosphere leaks away into the great expanse of space. It is a slow, silent exodus of atoms that have reached the very end of their journey with us. This process, known as atmospheric escape, is a natural part of a planet's life. It happens most often with the lightest of all elements, hydrogen and helium. Because they are so small and light, they sit at the very top of the sky where the sun's energy can give them a gentle nudge. When these tiny atoms gain just enough speed, they can overcome the pull of Earth's gravity and drift away, becoming wanderers among the stars. It might sound like a significant loss when we hear the numbers. Every day, the Earth loses about 90 tons of atmospheric gas to the vacuum of space, 90 tons of air simply vanishing into the dark. But in the context of our massive, beautiful planet, this is nothing more than a faint whisper. To understand how little this is, we must remember how incredibly heavy and vast our atmosphere truly is. It is so massive, so deep and dense, that even at this rate of loss, it would take billions of years for our air to disappear. We are in no danger of running out of the breath of life. The sky is a reservoir so deep that this daily leak is like a single grain of sand falling from a vast, endless beach. And the earth has its own ways of healing and replenishing itself. While some gases drift away, others are constantly being added back into the system. Deep beneath the crust, volcanic activity acts like the Earth's own internal respiration, breathing out carbon dioxide and water vapor from the molten heart of the planet. Even from the outside, the universe contributes. Occasionally, small comets or icy meteoroids enter our atmosphere, bringing with them new water and gases from the far reaches of the solar system. It is a grand, cosmic cycle of give and take, a slow, rhythmic exchange that has kept our world balanced for eons. You can rest easily knowing that the Earth is a master of self-preservation. Its protective layers are not fragile. They are resilient and enduring. This great blue envelope has shielded life through ice ages and heat waves, through the impact of ancient stars and the slow turning of the galaxies. It is a sturdy ancient cradle that shows no signs of faltering. As you breathe in the cool, still air of your room, remember that you are part of a system that is both delicate and incredibly strong. You are held safe within a bubble that has lasted for billions of years and will continue to protect the world for billions more. We are tucked away in a sanctuary of air, perfectly balanced between the deep earth and the high stars, protected by a system that knows exactly how to keep itself whole. As we hover here at the very limit of what we call home, we encounter a concept created by the human mind to help us understand the vastness of our surroundings. While the atmosphere itself fades into the dark in a slow, seamless gradient, we have drawn an imaginary line in the sky, a threshold that marks the transition from the world of air to the world of stars. This boundary is known as the Kármán line. It sits approximately 62 miles or 100 kilometers above the gentle curve of the Earth's surface. It is a quiet, invisible ribbon that circles our entire planet, serving as a symbolic doorway. In the world of science and international law, the Kármán line is the widely accepted edge of space. It is the point where we decide that the sky ends and the cosmos begins. For those who keep records of human achievement, crossing this line is a profound moment. It is the official marker for record keeping, determining where an airplane's flight ends and a spacecraft's journey truly starts. It is a peaceful realization to think that such a clear, defined boundary exists, even if we cannot see it with our eyes. It is a destination that represents our highest reach, a place where the rules of the world below begin to change. The reason this line was chosen is rooted in the very nature of the air itself. Below the Kármán line, the atmosphere is still thick enough, even if only slightly, to support the flight of a traditional aircraft. Here, the air provides what we call lift. Wings can push against the thin gas, allowing a plane to glide and soar through the silence. But as you climb toward that 62-mile mark, the air becomes so incredibly thin that it no longer has the strength to hold a wing aloft. To stay in the sky above this line, a craft can no longer rely on the air for support. Instead, it must travel at what we call orbital velocity, a speed so great that the craft essentially falls around the Earth, held up by its own momentum rather than the breath of the atmosphere. It is a beautiful shift in the physics of existence. Below the line, you are a creature of the air, supported by the invisible hands of the atmosphere. Above the line, you become a traveler of the vacuum, governed by the silent, rhythmic laws of orbital mechanics. This is why crossing the Kármán line is such a significant milestone for the few who have ventured so far from the ground. In the eyes of the world, crossing this invisible threshold is what officially makes you an astronaut. It is the moment you leave the cradle of the atmosphere behind and step out into the grand eternal hall of the universe. Take a moment now to imagine yourself at this very height, looking back down from the Kármán line. From this perspective, the layers we have traversed together reveal themselves in a stunning, silent display. You can see the deep, heavy blue of the troposphere hugging the ground, where the clouds drift like tufts of wool. Above that, the clear, calm stratosphere sits like a layer of still water, protected by its ozone shield. Higher still, you see the faint, ghostly glow of the mesosphere, where the shooting stars find their end, and the vast, shimmering expanse of the thermosphere, where the auroras dance in curtains of light. From here, the atmosphere doesn't look like a chaotic storm. It looks like a masterpiece of delicate, nested shells. Each layer has its own texture, its own temperature, and its own purpose. Looking down, you realize how thin our protection really is, a fragile, glowing veil that separates the warmth of life from the cold silence of the void. It is a sight that fills the heart with a sense of quiet wonder. We have climbed through the layers of the air, and now, as we begin to turn our gaze back toward the Earth, we can see how this magnificent filter shapes the very light that reaches our eyes. The atmosphere is not just a shield, it is a prism, and the colors it creates are the next part of our gentle journey through the sky. As we linger here at the edge of the world, take a slow, deep breath. Imagine the light of the sun as a gentle rain of white energy falling through the vastness toward us. From our high vantage point, we can see how the atmosphere acts as a master artist, painting the sky with the very light it catches. Down in the troposphere, where the air is thickest and life is most abundant, the sky is a familiar, brilliant blue. This happens because of a process called Rayleigh scattering. When the sun's white light hits the nitrogen and oxygen molecules in our air, the shorter, smaller waves of blue light are scattered in every direction, filling the dome above us with that soft, comforting color. It is a constant, radiant reminder of the protective blanket that surrounds us. But as the day draws to a close, the atmosphere changes its palette. Think of the sky at sunset when the world begins to quiet down for the night. As the sun sinks toward the horizon, its light must travel through a much longer path of atmosphere to reach your eyes. Along this extended journey, the dense air scatters away almost all the blue and violet light before it can reach you. What remains are the long, gentle wavelengths of mid-orange and gold. This is why the end of the day is bathed in such warm, sleepy colors. It is the atmosphere filtering the sun's energy, preparing the world for the coming darkness. If we were to rise again back through the layers we have explored, we would see this color transition in reverse. In the stratosphere, where the air begins to thin, the bright azure of the ground level starts to deepen. Without as many molecules to scatter the light, the sky loses its brightness and turns into a dark velvety violet. It is a color of profound depth, a shade of indigo so rich it feels like a heavy silk curtain being drawn across the heavens. At this height, you are seeing the transition from the world of light to the world of the stars. Higher still, as we pass into the thermosphere and beyond, the scattering of light stops entirely. There is simply not enough air left to catch the sun's rays and turn them into color. Here, the sky is a permanent, star-filled black. Even when the sun is shining with incredible intensity, the space around it remains as dark as the deepest midnight. It is a silent, eternal gallery where the stars shine with a steady, unblinking light, no longer obscured by the shimmering veil of the lower air. From the bottom to the top, our atmosphere acts as a magnificent prism, sorting the raw energy of the sun into the colors of our lives. It gives us the blue of a clear morning, the crimson of a peaceful evening, and the velvet black of the space that holds our world. It is a living, moving system that does more than just provide air. It shapes the very way we perceive the universe. This vast, multi-layered filter is part of a grander, rhythmic cycle, a system that moves and breathes just as we do. As we look down at the glowing curve of the Earth, we can begin to see the atmosphere not just as a collection of gases, but as the very breath of the planet itself. This breath of the planet is a rhythmic, living process that connects the soil beneath our feet to the furthest reaches of the sky. When we think of the atmosphere as a living system, we begin to see how every part of the Earth works in a slow, beautiful harmony. Down in the troposphere, where the air is thick and the forests are lush, the world's plants and tiny ocean organisms are constantly at work. Through the quiet process of photosynthesis, they produce the oxygen that we breathe. This oxygen doesn't just stay near the ground, it slowly drifts higher and higher, diffusing through the layers of the atmosphere to maintain the delicate chemical balance of the entire globe. It is a gift from the green world below to the blue world above. Beyond providing the air we breathe, the atmosphere acts as the Earth's great circulatory system. Imagine a soft, warm current of air rising from the equator, where the sun's light is most intense. As this air warms, it carries energy high into the sky and begins a long, slow journey toward the North and South poles. This constant movement of air acts like a planetary thermostat, distributing heat across the globe. By moving warmth from the tropical regions to the colder extremes, the atmosphere prevents the equator from becoming too hot and the poles from becoming too cold. It is this perpetual motion that keeps our planet habitable, creating the temperate climates where we can rest in comfort. The atmosphere is also a master of recycling, functioning as a giant, invisible conveyor belt for the building blocks of life. Every drop of water that has ever fallen as rain has likely spent time drifting through the atmosphere as invisible vapor. It gathers into clouds, travels across oceans, and eventually returns to the earth only to be lifted up again in a never-ending cycle of renewal. Similarly, the atmosphere holds and moves carbon, cycling it between the rocks, the trees, the oceans, and the air. It is a self-sustaining system that has been carefully managing the Earth's resources for billions of years, ensuring that nothing is ever truly lost. When we consider the vastness of the Earth, it is humbling to realize how delicate this protective system truly is. If you were to imagine the Earth as a large onion, the atmosphere would be no thicker than the onion's outermost skin. In physical terms, the atmosphere is roughly 1/100th of the diameter of the Earth. It is a remarkably thin, translucent veil stretched across the surface of a massive world. From the perspective of space, it looks like a fragile, glowing blue line, a thin layer of protection that separates the vibrant life of our world from the cold, silent vacuum of the deep universe. It is almost impossible to grasp how something so thin can be so powerful. And yet, within that narrow band of gas lies everything we need to survive. Every breath taken by every creature, every summer breeze, every fluffy cloud, and every quiet moment of sleep happens within this fragile envelope. It is our cradle and our shield, holding us safe while the planet spins through the dark. Now, having seen the vast scale and the intricate work of these invisible layers, it is time to begin our gentle journey back down. We leave the silent, dark heights of the outer edges behind and begin a slow, peaceful descent back toward the warmth and the light of the world we call home. As we begin our quiet descent, let your mind drift back through the layers we have explored, tracing the path from the edge of the void back to the warmth of your own room. Our journey took us through a vertical wilderness, a hidden architecture of gas and energy that defines the very nature of our existence. We started at the very bottom, in the familiar embrace of the troposphere. This is the realm of weather, where every storm, every summer breeze, and every gentle rain shower takes shape. It is the thickest part of our air, the heavy supportive blanket that sustains the life of every forest, every mountain, and every ocean. Within this layer, the cycle of water moves in a constant, rhythmic pulse, rising as vapor and falling as life-giving rain. Rising higher, we passed into the calm, dry stratosphere. Here, the air is still and clear, a place of profound stability. We felt the presence of the ozone layer, that invisible sun shield that absorbs the sun's harshest rays and transforms them into warmth. In this layer, the sky begins to change, moving from the bright blue of a clear day to a richer, darker violet. It is a place where the chaos of weather is left behind, replaced by a steady, stratified peace that protects the world below. Higher still, we reached the mesosphere, the middle layer, and the coldest place in our world. It is here that the atmosphere acts as a physical shield against the debris of the solar system. We watched as meteors, traveling at incredible speeds, collided with the thin air and burned away into streaks of light. These shooting stars are the visible sign of the atmosphere working to keep us safe, turning potential impacts into beautiful, fleeting moments of light. In the deep cold of this layer, we saw the ghostly glow of noctilucent clouds shining with the dust of the stars. Beyond the cold, we entered the vast shimmering expanse of the thermosphere. This is the realm where the sun's energy is most intense, heating the sparse atoms to incredible temperatures. We saw the curtains of the auroras dancing in shades of green and purple, a silent light show fueled by the solar wind and guided by the Earth's magnetic heart. We looked out at the International Space Station, a tiny speck of human curiosity orbiting in the silent height, proving that even in the thinness of the upper air, we have found a way to reach out and touch the stars. Finally, we reached the exosphere, the very edge of the envelope. Here, the atmosphere is so thin, it is almost indistinguishable from the vacuum of space. We saw the ghostly distant glow of the geocorona, reaching out hundreds of thousands of miles toward the moon, and felt the immense scale of our planet's influence as it fades slowly into the dark. We watched as individual atoms of hydrogen and helium drifted away, a slow and natural leakage into the great cosmic ocean. Every one of these layers plays a specific and vital role in the harmony of our world. They work in concert, a multi-layered shield that filters light, traps heat, and provides the very breath of life. It is a system of profound balance, a masterpiece of physics and chemistry that has existed for billions of years to keep the Earth a sanctuary in the cold expanse of space. Each layer is a different chapter in the story of our protection, a different note in the long, slow song of the sky. Now, as we leave these heights behind, feel yourself settling more deeply into the comfort of your bed. The air in your room is part of that same troposphere we first explored, a small, cozy portion of a global system. The oxygen you breathe now has traveled through these layers, cycled through plants, and moved across continents just to reach you. Let the weight of your blankets remind you of the gentle pressure of the atmosphere holding you safely against the earth. You are home, resting in the very bottom of a vast ocean of air, protected by miles of sky that stretch out above you like a silent, watchful guardian. Your breathing is slow and steady, matching the ancient rhythmic pulse of the planet. As you lie here, perfectly still, realize that the very air filling your lungs is a miracle of balance. We have traveled from the ground to the edge of the void, seeing how each layer of our sky works to maintain the sanctuary we call home. Consider the extreme environment just beyond those layers we visited. In the vacuum of space, temperatures can swing hundreds of degrees in an instant, shifting from searing heat to brittle cold. But here, tucked beneath our many-layered blanket, the atmosphere protects us from these harsh extremes. It absorbs the sun's energy during the day and holds on to that warmth through the night, acting as a gentle regulator that keeps our world at a temperature where life can thrive and where you can rest in perfect comfort. It also provides us with the gift of quiet. The universe is a place of immense energy and movement, But because sound requires a medium to travel through, the vacuum of space is eternally silent. Our atmosphere muffles the grand, distant echoes of the cosmos, creating a pocket of peace around our planet. It allows for the softest sounds, the gentle hum of a fan, the rustle of a sheet, or the steady rhythm of your own heart to be heard, while keeping the vastness of the outside world at a distance. It is the silence of the sky that allows for the stillness of your room. Think of the sun's light, which would be blinding and white in the void. Our atmosphere takes that harsh radiation and scatters it, turning it into the soft, usable glow that fills our days. It filters the rays to create the deep blues of the afternoon and the gentle, sleepy oranges and purples of the dusk. It is a great global prism that colors our lives, softening the world so that our eyes and our minds can find rest when the sun finally slips below the horizon. In this stillness, remember that the air is the most fundamental thing we share. It is a common thread that connects every living creature on this planet. The same molecules of oxygen and nitrogen that surround you now have passed through the lungs of ancient forests, have been moved by the wings of migrating birds, and have drifted over vast, untouched oceans. When you breathe, you are sharing in a deep biological history with every creature that has ever called this earth home. It is the ultimate bridge between us all. As you take a slow, deep breath now, you are actively participating in this great global cycle. You are drawing in the gift of the trees and the oceans, a testament to the planet's constant work to sustain you. With every exhale, you release a part of yourself back into the system, contributing to the movement of life that never truly stops. It is a quiet, rhythmic exchange that happens thousands of times a day, mostly without us ever noticing, yet it is the very foundation of our existence. You are part of the Earth's breath. The atmosphere is more than just a collection of gases. It is a cradle. It is a soft, invisible structure that holds us safe while we sleep, shielding us from the cold, the dark, and the debris of the stars. You are tucked away in the most protected place in the known universe, wrapped in miles of sky and held by the steady pull of the earth. Let your mind drift now, as light and unburdened as a wisp of vapor in the high stratosphere. The journey is complete, and the world above you is standing watch. There is nothing left to do but let go and rest. Sleep well, protected by the sky. Good night.